Well, hello everyone, and welcome to another episode of Power Logic. So today, I'm gonna be introducing you guys about a really interesting concept, which is conic area through calculus. Which really specific is gonna be integral. So let's start. So first, we're going to start with circles. We're going to start with circles. And let's say if this is the point, the origin, and we have this is equal to r. A, which this is the center of the circle. So we're on the coordinate plane, then the equation of circle is always going to be x squared plus y squared is equal to a squared, which a is the radius in this case. So we're going to have y squared is equal to a squared minus x squared. By isolating y squared out, then y is going to be equal to the square root of a squared minus x squared. Now we know that we're not considering negative value because you obviously cannot have an area of negative. So well, now we are evaluating this region. Okay. Now we're evaluating this region. So we're trying to find this function between, so the area between this function and the x-axis. Now we're going to integrate this. When that taking integral is basically find the area under the curve. Then we're going to take the indefinite integral first, and then we're going to take the boundary. So I have integral of square root of a squared minus f squared dx. Now using the trigonometric substitution, well, assume this is a right line. No, this is a straight line. Actually, I'm gonna redraw it. Now we have a triangle. We have a right triangle here with oh, this is a right angle. Then let the hypotenuse be a. We have ax in square root of a squared minus x squared. So now to do the trigonometric substitution, we're gonna set this angle be theta. Then we can see that a sine theta is equal to x over a. No, it's equal to x since I already divided. So I have a sine theta is equal to x. So now we have the value of x, then we're gonna put it back, which this integral just becomes the integral of a cosine theta. But now it's not done because we still have the dx term. But dx is really easy. So dx is just equal to a cosine theta equal to dx. To derivative, you guys can check the value of integration. He explained it pretty well. He explained it pretty well. So now, since we multiply this by the same thing, we're gonna just square. And don't forget a d theta. So now we drag it down. What just happened to this? I don't know. Okay. There's something going off. Okay. So now we have this value, right? So now what we're gonna do is we're gonna take the a squared out, which is a squared integral of cosine squared theta. Okay, so now what are we gonna do is we're going to, let me just take this away. I'm going to find this integral, the integral cosine square theta. With the identity that cosine square theta is equal to 1 plus cosine of 2 theta over 2. Then we're going to have a square over 2 times the integral of 1 plus cosine of 2 theta. Which now we're going to use the fundamental theorem of calculus. We turn this into a square over 2 times, sorry, this seems like negative. A square over 2 times integral of 1 d theta plus a square over 2 integral of cosine of 2 theta d theta. Well, now we know that 1 d theta is just equal to theta when taking integral. So we're going to have a square over 2 theta plus a square over 4 times sine of 2 theta, because we have the unbounded chain plus c. And this is our integration, but now we're going to take in definite integral. So now we're going to evaluate this from a to negative a. But we have to going back about theta. We can't just leave it in this level because what is theta? So we remember that theta is equal to arc sine of x over a. Right? So now just plug it back in, then we're going to have a square over 2 times theta, a square over 2 sine negative 1, x over 2, no, x over a, plus a square over 4 times sine of 2 theta, which is sine, well, sine of 2 theta is equal to 2 sine theta cosine theta. So now we'll just take it back. We have, well, remembering the identity that sine of 2 theta, but I just showed it over there, that's meaningless, equal to 2 cosine theta sine theta. So now minus a square over 4 times sine of 2 theta, which is equal to a square over 4, but we multiply by 2, then we're going to have, still we have a square over 2 times a square over 2 times cosine theta. Well, theta can also be equal to our cosine of square root of a square minus x square over a. So we're going to have a square over 2 times x over a times square root of a square minus x square over a. And then we want to take this integral from what? From a to negative a. And then the entire thing, the 2, is going to be our area. So now, let's just try to evaluate it. So we have a square over 2 times sine of negative 1a, which is equal to a square over 2 times 2 pi. Yeah, a square over 2 times 2. A square over 2 times 2 pi. Plus a square over 2 times 1 times a square minus a square, which is equal to minus what? Minus a square over 2 sine negative 1 negative a over a, which is we take the principal value, which is going to be equal to sine of negative 1 of negative 1. Well, this is always going to be not mattering because we know that this is always going to be 0. So we're going to have this subtract by a squared over 2 times sine of negative 1 of negative 1. And this entire thing multiplied by 2. Which, well, this is equal to a squared pi minus a squared 2 times sine of negative 1, which is this is equal to pi. Minus a squared pi over 2. Entire thing multiplied by 2, which is equal to a squared pi over 2 times 2, which is equal to a squared pi. And thus getting our desired answer. Thank you for watching. Hope you enjoy and have a great day.